Hello, and welcome to Pulumi TV. My name is Mike Metrol. Pulumi is a modern infrastructure as code tool that allows you to declaratively describe your cloud infrastructure using real programming languages. Pulumi helps developers and operators work seamlessly together by helping to drive cloud adoption much faster. We support many languages such as JavaScript, TypeScript, Python, Go, and .NET across the major cloud providers and Kubernetes. In this episode, we'll give an introduction into our latest SDK, KubernetesX. Let's begin. In this episode, we'll cover 3 different usage scenarios where you can leverage Pulumi to work with Kubernetes. First, we'll use Pulumi to deploy standard Kubernetes YAML manifests that any user of Kubernetes is accustomed to working with. Then we'll showcase how to use Pulumi's Kubernetes SDK to deploy resources in the language of our choice. These are deployments and service and config maps that you're probably used to working with. And then lastly, we'll showcase how to deploy the same resources using our Kubernetes X SDK, but using less code, less boilerplate, standard defaults, and just an overall improved authorship experience. Let's begin. When working with Kubernetes, you're going to actually work with many different layers and stacks, provider all the way up to the apps. As you can see, the level of configuration that you can have is going to depend on how much infrastructure control you need to provision, but also manage. We offer many different SDKs, as noted on the left-hand side, that allow you to service each of these layers. For example, at the bottom, you can leverage the Pulumi AWS, GCP, Azure, and AWS X SDKs to provision the standard IaaS components you're used to working with, like VMs, virtual networks, IAM, and registries, using languages instead of YAML, JSON, or templating. We can use the same SDKs if we move on up the stack to provision the managed control plane of our Kubernetes clusters. Then, once we have a cluster up and running, we can leverage the Pulumi Kubernetes and KubernetesX SDKs to then configure and deploy the cluster services, app services, and the apps we wish to run in our Kubernetes clusters. Let's see how we can leverage some of these SDKs to work with Kubernetes. We're going to be deploying a demo app across the 3 usage scenarios we outlined in the previous slide. The details of the app need not matter, but what we are going to focus on is the resources in Kubernetes used to compose our app. At the center, we have a container that's wrapped in a deployment. This deployment will have a config map attached to it for data, a secret attached to it for secret data, a volume for persistence, and a service to expose this deployment outside to the world. We're going to review how we can deploy this demo app as a component resource, which is a custom resource in Pulumi, using the 3 different scenarios we outlined previously. Let's check out what that looks like in our editor. Here we have a typical Pulumi program. We import the various SDKs using the language of our choice. In this case, it's TypeScript. We'll create a provider in Kubernetes, which is simply just a wrapper around the kubeconfig file, and optionally, a namespace to work within. We'll take this provider, and then we'll pass it on to our 3 different usage scenarios. Deploying an application using a YAML manifest, deploying the same application using Kubernetes resources, and then deploying the same resources but using our Kubernetes X SDK. Let's see what it looks like to work with YAML manifests. Here we have a component resource that we've created for our custom need. As you can see, we've called it Demo App, so it's a new class that extends the Pulumi component resource. In this actual object, we will have a constructor, some properties, a supercall, and then we can actually get into the nitty-gritty of our details. In this case, since we're deploying a YAML manifest, we're going to actually leverage a sub-resource in the Kubernetes SDK that we imported from Pulumi SDK using Node, in this case, npm. And that's going to point to a local file on our file system where the actual resources are described. Once we deploy this manifest, we'll then pull out some information to display its URL. Let's see what that manifest looks like. If you've worked with Kubernetes, this look this should look familiar to you. We have a deployment of Nginx that deploys the Nginx image, references a config map, references a secret, has ports, resources, has volume mounts for a persistent volume claim that we also instantiate. Here we describe the config map. Here we describe the service that exposes this application using a public load balancer, the secret that will be mounted in, and lastly, the persistent volume claim that will mount a volume into our application. This should be standard for most folks who work with Kubernetes and who have worked with YAML manifests. So as you can see, we don't have to migrate our entire set of resources from YAML into TypeScript, which we're using here, if we don't want to. This allows you and gives you the opportunity to find some sort of halfway point between migrating between standard YAML manifest management and managing your resources through Pulumi in the language of your choice. Now let's see what that looks like deploying the same application using our Pulumi Kubernetes SDK. Here we have a second demo app class, but under the Kubernetes namespace that we've identified in our program here using the K8s app from our local file that describes it. In this app, what we have are similar properties. You have a config map, a secret, a persistent volume claim, a deployment that references the config map, secret, and persistent volume, a service to expose it, and then the URL which we're going to extract from it. As you can probably tell, this looks very familiar to the same standard deployment spec we're used to working with, except we're doing this in TypeScript. To compare, look at the YAML manifest we have before. The deployment looks pretty similar. Here we have it in YAML, and here we have it in TypeScript. Pretty similar, huh? This allows you to not only describe your resources using real languages, but because I have languages at my disposal, I have abilities that YAML and JSON and other languages that aren't full languages, unfortunately, don't employ. For example, I can reference the name of the persistent volume much like I would any object in any given programming language. I do that for my persistent volume claim. I do that for the secret. I do that for the config map. I can reference objects for labels that I've defined up here. I have the ability to have my IDE tell me when my spec is mismatched. It says that this property doesn't exist. I also have the ability to jump into the documentation for the properties of my choice. So languages at the gates offer a lot of benefits over standard YAML and JSON. And this deployment of this application is going to be the same semantic output as you would expect using the YAML manifest, but we're doing it natively in the language of our choice. Now, let's see how we can do that in the Kubernetes X SDK using a similar approach. For reference, in our Kubernetes SDK, the one we just showed, we approximately have 106 lines of code. As you can see, languages are powerful, but they don't really reduce the amount of boilerplate needed when you compare it to, say, YAML. In our Kubernetes X SDK, we've gone from 106 lines of code of Kubernetes code in TypeScript to just 61 lines of code. So to compare 106 lines of code, 61 lines of code, that's a reduction of just over 40% of code lines that we've removed from our actual source, and it just looks cleaner. We have the same config map, we have the same secrets, the same persistent volume claims, but now we've introduced a new concept of what's known as a pod builder that starts with a root object and builds around it. So we can define our set of containers that will be living in the pod as such. As you can see, we already have standard approaches to defining our environment variables in a key value approach. This is very different depending on where the environment source will be coming from in Kubernetes. So just out of the gates, being able to simplify environment definitions, for example, reduces several lines of code compared to YAML. See, in here we have approximately about 20 lines of code just to define the environment variables. The same can be done through referencing a config map and a secret in a consumable way through this function, or rather method, that exposes the data in these objects as values sourced and ready for environments. We can take advantage of many different properties of the language to reduce the boilerplate and ultimately improve the authorship experience. We don't create any new nouns, we don't create any new resource methods, or for that matter, revamp the spec at all. What we do is we reduce the boilerplate as much as possible while still giving you the option to drop back into the Pulumi Kubernetes SDK to have the full spec as you would expect it to be for config maps, secrets, persistent volumes, deployments, etc. So if for some reason the KubernetesX abstraction, or rather helpers, because that's what they really are, they're helpers, if they don't quite cut it for what you need to describe, you can always fall back to the raw Pulumi Kubernetes SDK to get the full spec at your disposal for the resource that you're working with. For most cases though, Pulumi's KubernetesX SDK is actually quite powerful, and the authorship experience is not only much more improved, it's easier to read, it's easier to digest, and more so, it's just easier to decompose and stitch together properties. But the main thing to take away from this for KubernetesX is that even though we're writing new code depending on the library that we're using, what's actually happening is we're producing the exact same semantic output type you would expect for a pod, for a deployment, for a service, for a persistent volume claim, a secret, and a config map, and the rest of the resources offered in Kubernetes. We just leverage code, encapsulation, and the ability to abstract away the nitty-gritty to improve the experience when you actually stitch these together. If we were to run the actual program, we are going to get 3 different deployments, one for deploying through the YAML manifest, a second one for deploying using the Kubernetes SDK, and one using the KubernetesX SDK. And all will be deploying the same application and exposing it to the internet. Let's pull up my browser to see what these URLs look like. There's Nginx using the Kubernetes SDK. There's Nginx using the KubernetesX SDK. And then lastly, we have the ability to actually check out the one for YAML. Great. All produce 3 running copies of Nginx in the same semantic way. Each of these choices allows you to approach Kubernetes with Pulumi in the familiarity and the level of intensity that you so require. There's trade-offs to each approach. YAML manifests give you the benefit of migrating slowly to Pulumi if you've come from an environment that still actively works with YAML manifests, but still are intrigued to actually leverage a resource such as Pulumi that has the power of programming languages behind it. The Pulumi Kubernetes SDK allows you to then use the full SDK's capabilities around any language that you're supporting to deploy and manage resources in Kubernetes, but doing it in a real language. And then the KubernetesX SDK is an improvement on the Pulumi Kubernetes SDK to reduce the boilerplate needed to work with resources and just overall improve stitching resources together. Last but not least, I wanted to take this opportunity and showcase one preview feature that we've supported, and that is the option to leverage Pulumi to render and generate YAML manifests using the language of your choice. This is typically for folks who are still traditionally working with YAML, but want to use the power of a programming language to proactively and programmatically construct these resources rather than leverage a templating engine. What does that look like? Well, let's make a couple of changes. As we noted earlier, a Kubernetes provider is simply a wrapper on a kubeconfig file and optionally a namespace. To work with a provider that allows you to generate YAML instead of deploying resources into a cluster like the Kubernetes SDK and the KubernetesX SDK do, we're going to change the providers just slightly. So, as an example, I'll do this with the Kubernetes X. I'm going to swap out the provider that we use here. So in this declaration, we created a new provider called the render provider, which will render YAML from the resources we've created directly onto a directory locally on disk. We'll swap out the provider by just swapping these two out. And let's rerun this just real quick. So now we're going to do a Pulumi update. And what we've done is we've pivoted the KX resources that we've described from deploying it into a cluster to then rendering YAML locally, so that way we can deploy it using, say, kubectl if we want to use that approach. So what's going on here is that we're removing the data that was created, in this case, the resources that the KubernetesX SDK created for us, and instead, we're going to actually render YAML. Let's wait for this update to finish. This may take a little bit as we have to deprovision the load balancer that we've created on the previous run. And we are complete. So as we've noticed, there is a new directory called rendered. What does that look like? If we look into that directory, if I had CRDs, we would be seeing the rendering of that in this directory. Because we don't have CRDs, we can skip that step. But in the objects that did render, you can see that I have actual YAML manifests rendered from Pulumi TypeScript that allows me to leverage the language to do referencing, to leverage all the gains I've seen of my IDE and just leveraging a language in general, and more so, just the reduction of boilerplate that I have to work with compared to, say, YAML. So if I check this file out, here's the config map as we would expect it in YAML. Similarly, let's look at the deployment. Great. All looks well. If I were to deploy this, I can say, create this in a new namespace. I'm going to say new namespace, create namespace, my YAML. I have my kubeconfig file over here, so let's see what this looks like. All right, let's move into that. Okay. I'm going to take this kubeconfig file and just use it over here. We'll export it to use kubectl. And we can now see that it's working. Great. Now let's actually create a new namespace again, my YAML, and we're going to deploy this folder that's been rendered for us into that namespace. And we can then see that in this folder, we can do a recursive add of that, and all of our resources are created, just like we expect them to be. Get all from the my YAML namespace. And sure enough, these resources are slowly coming up. As we've seen, we can use Pulumi to deploy YAML manifests if we are coming from a YAML manifest world. We can use Pulumi with our Kubernetes SDK to deploy Kubernetes resources in the language of our choice. Or we can use the latest KubernetesX SDK to deploy resources using less code, less boilerplate, and standard defaults. Here are a couple references for you to work with Pulumi and Kubernetes. Here's a link to our Kubernetes SDK, our KubernetesX SDK. Here's a link for some tutorials to get you started. And if you're familiar with our Pulumi TV repo, our code is available and accessible on GitHub. For those of you who haven't visited, please come and check it out. Give us a like, share, open up an issue, or share it with friends. We hope this has been helpful for you, that you've learned the various ways you can use Pulumi to work with Kubernetes. And if you have any feedback, please let us know. That's all my time for today. Thank you, and have a great day.